now I'm doing a bit of everything, but mainly programming at KillHouse Games. We founded the studio in 2014, and we released our first game, Door Kickers, and now we're working on the second game. Is anyone here who doesn't know about Door Kickers? Oh, that's pretty good. I assume you're all the sales we made in Romania then, because out of 300,000 copies or so on PC, we only sold 300 in Romania. So I guess Romania is not a good market for selling video games, if you are thinking about it. Is this synced now or not? Ah, okay. Sorry about that. Okay, I'll get straight to the point. What's this about? Well, after creating our studio, we spent big money on a third-party engine. We quickly put together our game, which was buggy and unfinished, and we gave 50% to a publisher. Obviously, I'm joking, because otherwise this talk wouldn't make much sense, right? We actually did quite the opposite. What if I told you there is value in not using a third-party engine? You can do things better and faster and cheaper and overall more awesome by building your own technology. Okay, I'm having a bit of technical issues here with the slides. Okay, so if you're using Unity or UDK, don't leave out just yet. Actually, everything we did can also be applied on a third-party engine or whatever. So, how did we do it? I'm going to make an analogy with this piece of art right here, which I assume you know. And believe it or not, this is a bird. The artist, which is Brâncuș, actually wanted to make a bird, but he didn't want to make any bird. He wanted to catch the essence of a bird. So he started from a real-life bird, and he started removing the head, the feathers, the wings, and everything, until only the essence remained. If you ask me, abstract art is silly, but I like the approach of it. So I thought, okay, maybe we can apply the same to game technology. Okay, so initially I didn't think about writing a presentation about our technology because I thought it was just too simple. Nowadays everything is about the next AAA stuff and the next DirectX or anti-aliasing technology. But after reading development blogs and watching other indies, I realized that they're having much trouble because, I don't know, in spite of all the available tools and access to information we have right now, they're simply not making games fast enough. And maybe they're overcomplicating the process. Instead of going after AAA quality, they should go in the other direction, which is to simplify everything. And that's what we did. We simplified everything. If you think about it, simpler is faster, cheaper, more efficient, and more reliable. And to prove it, our game runs on any kind of hardware, no matter how old it is, even on mobile hardware, 60 FPS. We have almost no bugs, no crashes. We very rarely receive a gameplay crash or something, except for some issues with drivers. Okay, so what we did is instead of adding tech, we removed tech. And we kept removing until there was almost nothing left, just like in the bird example. And let's see how basic we can get. If you don't know our game, this is it. And I'll show you a quick trailer. It's the iPad trailer because it's shorter. And the game is a tactics game released on 5 platforms: Windows, Linux, Mac, iOS, and Android.
Tango down.
Okay, so it's not that simple, right? It's not AAA, but it's not the 80s either. It's the biggest thing about our game, and what made it attractive, I think, was the control system, where you simply draw where your troopers want to go and you draw their commands. It's a free-form control scheme. It was initially envisioned for mobile devices with touch screens, but we thought we don't have any experience on mobile, so let's go on PC. It was pretty successful for an indie game. We received a bunch of good reviews. We sold many copies, and we also made some money. We still don't own a Ferrari yet, but after this presentation, maybe. But I believe a big part of the game's success comes from the development efficiency, and that's what I'm going to talk about next. If you remember the 90s, games back then, even though some of them were much more complex than today's, they were developed in only a fraction of the time. If you know Doom or Wolfenstein, for example, Wolfenstein was made in just half a year. And that's happening even though we have much better access to tools and information today. There are many reasons for this, and it depends on the game, obviously, but the overall feeling is that of much higher efficiency back then. Where did we go wrong? Can we create games faster without taking years, and also successful games? Maybe we're overcomplicating the process, right? That's what I'm thinking. So, as a proof of concept, I'll talk about Door Kickers, obviously. It was written from scratch. We did everything by ourselves. The engine was made in just 3 months, mainly one programmer initially. It's available on 5 platforms, and we only spent $1,500 to make it. That's until we started making money. So about in 3 or 4 months, we only spent $1,500. To brag a little bit more, the game has over 100 maps modeled after realistic buildings. We have a random mission generator having almost infinite replayability, and we have modding support with thousands of mods on Steam Workshop. Okay, so why do it? Why roll your own tech then? Because common sense says you can do it faster with a third-party technology, right? Well, first of all, you'll have a limited budget. We all have it, whether be it time or money. So just learning UDK or Unity can take up to 4 months if you don't have experience in them. I didn't. And obviously they cost money, whether through royalties or upfront costs. And for indies, that might mean your entire budget. This is a really important one. Using an engine raises expectations, which in turn equals more development effort. I've seen this countless of times. If you have support for awesome features like physically based rendering or whatever, that you can just tick a box somewhere and they'll just work, you'll want to use them without thinking that they are really important for your entire data pipeline and whatever you do next. And I've seen games which look quite decent for indie game, but you need 3 video cards to run them. And this is a mistake most people do using third-party engines. Okay, and this one is obvious. You'll obviously learn something in the process, because what are you going to write in your CV? Unity or UDK programmer or artist or whatever. It's not okay. And tools come and go, but your knowledge of what's beneath the hood of those tools remains. And this is what's really important. Also this, but besides the name, is not only being cheap, but from the sale price of a game, we as an indie developer without any publisher or without any paid tools we only get something like 45% of a sale price. But think about it, if you have a publisher that usually takes 50% of that, and you have UDK that takes 10% or something of the gross revenue, and that's not the net revenue, you usually get much more below 20% or something. So it's not good money, especially for an indie developer. So again, can we make something so awesome that it outweighs the benefits of using a third-party engine? Again, I'm not saying third-party engines are bad, but you can do it better, but by just thinking beforehand about what you're going to do, technically speaking. And most people don't do that, probably because lack of experience or something, but you just need to do your research. And instead of ticking checkboxes all over the place in Unity, you can think about where you want to go, technically speaking, right from the start, and think a strategy related to that. Obviously, you need to know where you're going. If things are going to change, it's not good. Usually, this doesn't work well with design and technology because design usually changes, and no designer on earth will know right from the start. But there are some major points you can discuss, like will we have single player or something like that, which will affect your technology. Embrace limitations, because efficient development is about limiting technical features, not adding them. Don't think about sequels and what awesome thing you're going to do on your next game. Think about making this game the best game possible yesterday. And I've seen games where they start as an FPS and afterwards they're going to want to make it an MMO where you can run around the ships or something, and that's not good. And even this applies even for simple things like an animated UI. Do you really need it? I've seen AAA games that don't have animated UIs. So you can put some of those things away. And obviously ask not what you can add, but what you can remove. So let's start removing. Do you want to do a standalone editor? That we don't want to make another UDK, right? And this is going to take you at least 3 or 4 months. What we did was implement our editor directly in game. It uses the same game code, so we're not duplicating anything. It works on the same code. It works on the same file format. You don't have to go through importers and exporters between editors and the game. And it just works. The downside is that it's really hard to implement UIs, so you have to limit yourself in not exposing, I don't know, color controls or any kind of option in the editor. I'll talk about that more later. Scripting AI, if you've scripted AI before, I feel your pain. What we did is sandbox behavior. You just place an AI in a game, on a map, and it should just behave properly. Obviously, it's a lot tougher to do than talk about it, but it's what you must do to do this. Okay. UI editor, obviously we don't want to make another Adobe Flash. What we have is a simple system where we just hard code buttons and all coordinates in a simple XML files, which looks like this. And we have a hot reload button. We just modify the X and Y pixel coordinates. We hit reload and it instantly reloads. And the UI doesn't look that bad in our game, so this works. And I've seen countless of games where you have 30 FPS in the main menu, and I hate those. I usually just quit immediately after. Let's remove some more. Particle system, it's hard alone just to use one, let alone create one. So what we did was create animation sprite sheets with all animations in the game. So even if we had some very large and complicated animations like snowfall, we just rendered each frame for all snowfall on the entire screen 30 times or something, and we have sprite sheets for each of those frames. Considering current hardware, where on PC at least, it's not a problem for us, especially for this type of game. By now you're probably asking, okay, we've removed everything, what can we do? Well, we want to do this. We should just place images on the screen and everything should just work. When we first started, I imagined this workflow. The artist should make an image, a designer adds that image to the map, and everything works, right? You don't need editors, you don't need anything whatsoever. To make a game in 3 months or less, that's what you need. This is the editor. This is the way it's shipped. On the right-hand side, you have objects, and you just click on them, place them on the map, and that's it. Later on, we added some fluff for mothers, but this is how it's shipped. By now, you're thinking this probably when I'm saying engine, and I won't blame you. But what if I told you that we actually developed the best engine in the world? Yeah, we did. And why? Because you've probably heard about unified lighting or something like that again. But what we actually did is unified everything. Let me say that again. Everything. You've never seen that before, trust me. Okay, I'll go back to that a bit later. But some other reasons why it's the best. Because it was cheap, we didn't pay a cent on it. It has very few bugs because it's so simple. And we invested $1,500 and we made over 2 million out of it. So about that unifying everything stuff. Obviously, I thought right from the start, it's a 2D game. What is the lowest common denominator for all systems in a 2D game? It must be something related to images, right? So we must use an image-based approach for all systems. If you don't know the Bresenham algorithm, it's an algorithm where you trace a line to an image, and you say the line goes from A to B, and this is the pixels it will touch. It's a 30 line or so of code, 30 lines of so or code. And this is our engine, basically. I'll show you. Okay, so this is the workflow under the hood. We render all entities in a single image. And from that image, we generate everything. Collision, pathfinding, lighting information, shadows, and everything. I'll start with the collision detection. This is how it looks like. Every image we render with an ID so that we know it's a car, it's a toilet, it's something. And to check for collisions, we simply trace using the Bresenham line. For example, for bullets, okay, the bullet goes from here to here and it will touch this car and this AI or something. It's very precise because it's pixel perfect, right? And it even works for dynamic objects because we only write the, the silhouette for those using the same Bresenham algorithm. And for humans, we draw the silhouette, and the next frame we erase it and draw it again on the new position. This is how it looks like. We actually downscale it because otherwise it would be too big to have it screen size. And we downscale it 8 times or something. And since we have a big image with all the objects in it, obviously A star works on grids, so we can use A star on the same image for pathfinding, so that we know where a character needs to, how he can get to a place. And since we're using the same image, A star gets updated real time using the same objects, dynamic objects and everything we also use for collision. So pathfinding and collision detection on an image, that's it. This is how it looks like in the alpha channel, where we also adjust some costs. Okay, for field of view, there are tons of algorithms. What we do is just trace 360 rays around each character using the same Bresenham, and we see what object it touches, for example, what AIs a human sees, and we pass it to the AI system. And obviously we're using the same contour after the ray tracing to draw the what's the visible field of view. We're also doing this for enemy AIs, but we just don't render those. For big maps, it can get quite heavy with thousands of rays. And this turned out to be a non-problem because the Bresenham is fast enough to do it. And we can have 40 or 50 characters moving real time, and there's no problem. We only had to do an optimization on mobile, where we had to multi-thread it, but that was it. For lighting, we just do, and if you know screen space ambient occlusion, we do something similar but in 2D. For each point, we draw the same 360 lines, and we know how much an area is occluded. And we also have directional shadows, where we just smudge the shapes in a direction. And it's a gross fake, obviously, but it looks decent and nobody complained. So this is unified everything. We're using one image to do collision detection, field of view, lighting, ambient occlusion. We're even using it for sound, where we're applying dynamic sound reverb, depending on where you are, because we're doing the same thing for sounds, where you trace lines around you and you gather what they hit, and you know, okay, I'm in a toilet now, and toilets are supposed to have a high reverb, right? So we apply reverb for that area. And we're using one image, so the same data set for everything in our game. And there is no need to define collisions or anything in a third-party editor, where you would usually have an object and then you'll have the artist go and create a collision, a fit collision box for it. We just create an image, put it on screen, and it will have pixel-perfect collisions. Also, no lights properties, AI properties, or nothing. So, if it's not simple enough, we did some other things. Okay, so we only have 3 formats, file formats in our game: an XML, TGA, and WAV. These are basic uncompressed formats. They load fast, they need very few code lines, and this is basically it. Uncompressed file formats, only 3 of them. We only added compression on mobile, because on PC this wasn't a problem, but for mobile you will hit some limits. Okay, so one of the biggest issues importing the game on multiple platforms is the graphics API, where if you're using DirectX on PC, you're going to have a hard time porting it on OpenGL on other platforms. So if you know Open Mobile, you'll know that it uses OpenGL ES2 on iOS and Android. And ES2 is a subset of the PC OpenGL. And if you're using only functions of that subset, the same game will run on PC and mobile or everywhere. So right from the start, we used only functions from OpenGL ES on PC. And when the time came, we ran the game on mobile and it just worked. Okay, what else can we do? You probably know this line. Premature optimization is the root of all evil, but it can also be applied to data. So we don't have any texture atlases in the game because 99% of the games out there won't need it performance-wise. You only need it for big AAA games. Otherwise, it won't matter if you sort by texture or something. So if you have texture atlases, you'll have to rebuild your data, and every time you update a subtexture, you'll have to update your atlas, and it just adds to the time, right? Another thing is we don't have any compression methods or something. We just have the raw files just dumped on the HDD. So we have those TGA, XML, and WAV files there. We don't use anything special or to obscure them or whatever. It just makes modding easier, right? Our game was about 1 gigabyte of data, so why bother optimizing that? For PC, it makes absolutely no sense for today's hardware. We also, related to this data, being only 1 gigabyte of uncompressed data, we can keep that all in memory, right? In our game, we never free anything. We keep everything in memory at all times. That's why we have very fast loading times. And 1 gigabyte of data, what's that for 4 or 8 or gigabytes of RAM, which is so common nowadays. For animation sprites, since we don't have texture atlases, we just make all sprites like this. They're centered on a grid cell, which is the size of the largest animation frame. And it's obviously a huge amount of wasted space, but since we don't have atlases, whatever, and space is of no problem. And code-wise, this is much, much simpler than having an atlas or something. You can having same-sized animation sprites. That's cool. And this is what it would look like in a proper game, you know. And I don't know, quarter the size or even less. But why bother? So if you thought that implementing the game on multiple platforms was hard, I'm telling you that it isn't. For porting on multiple platforms, this is our entire layer. We have 9 C functions that when we port to a new platform, we just rewrite these 9 C functions and everything works. And depending on the game, you might not even need half of them or something. Probably don't need, I don't know, to retrieve the supported display modes on iOS or something. So many people use frameworks like SDL, but usually those have become very bloated in time, and they're huge and hard to use. So this is much, much faster, trust me. Still related to porting, actual implementation on OS X and Linux took less than installing the operating system and all the chain of tools required. And since we did the OpenGL stuff and everything, I don't know, it took us 1 or 2 days each. And very few modifications afterwards, but those are obvious. It's trickier on iOS and Android because of the large amount of aspect ratios and resolutions. And what we did was just make 2 or 3 versions of the UI. We had a UI for 16:9 aspect ratio, one for 16:10, and one for 4:3. And we just interpolated between those when some aspect ratio wasn't quite hitting that ratio. We're also currently considering porting the game on Vita and Wii U, which also uses variants of OpenGL, and it's pretty easy. Okay, so I'm not saying we found a silver bullet here, but I'm just saying that you can do awesome games, great games, successful games without taking many years, without spending a lot of time on tools and whatever. So if we can do it, anyone can. And obviously this probably won't work for a AAA game or something. And also if you switch your data pipeline mid-production, obviously it's not good. Okay, so that was it. Thank you. This was supposed to be some Steam key codes for the game, but since I think it's not the latest presentation, this might be taken already. So sorry about that. If you can switch to the new presentation to the last slide, it would be just fine. Okay, if you have any questions, please shoot. Okay.
So you said you spent $1,500 in the first few months. What did you spend it on?
Okay, so for example, when we wanted to make sounds, music and sounds for our first version, we talked to an English guy, an American guy, and a Romanian guy. The English guy asked for £4,000. The American guy asked for $6,000, and the Romanian guy asked for €500. So that's a big chunk of that. I'm guessing you know who he went with. And besides those €500, we spent on the website, some freelance art, and that was, I don't know, €300 or something, because we did most graphics by ourselves. It was pretty rudimentary initially because we didn't have money. After the game started selling and it did quite good, we had money to improve it. And what you're seeing now is much better than it looked like initially, much, much better. So it looked really bad, but that just adds to the point. The game worked without having great graphics. And I think that was it. Legal costs for creating the company, and yeah. What you?
So you didn't include your salary?
Oh, the cost of life obviously is not included. Yeah. Yeah, that's what you must do. You put money aside and you make, that's what our budget was, to make it in maximum at tops 6 months, or otherwise we're back to work. So that's why I did this. Okay.
So now if you're going to develop another game, you're going to develop another engine?
We're actually working on the sequel, which is fully 3D right now.
No, a different type of game.
Oh, a different type of game? We're not going to do that. It would be a bad idea not to capitalize on the success of the first one, obviously. And we're rebuilding our engine, but still doing the same tricks and reusing much of the code that we used for the first one. Obviously, not everything is going to work the same as the first one because we're now a 3D game, but most things do. So, okay.
How would you say this engine would scale for a bigger game or more content?
we, there isn't bigger content than our game.
Someone would like to use it for something?
I don't know, it depends on the game, obviously. Our game was limited in map size, for example, is one limitation, because since we write everything in an image, we require that image to be full size. And if your map is 4K by 4K, you need support for a 4K by 4K image. And you can't have maps that have 10 kilometers or something in size. It will need adjustments, but that's one of the limitations. Yes?
How much programming experience did you have to start?
Okay, so how much programming experience? I don't know. I personally, as I said, work for Ubisoft and EA, so I had about 5 years working professionally on games. And before that, I used to work at home for, I don't know, some years. But
You mentioned that the one was local, but I was thinking if somebody doesn't really know all the aspects, I mean, you are able to identify what you want to do. But if you're somebody that's just starting out, you're not all the tools, because you don't know what kind of algorithms you're going to need beforehand. You don't know how you're going to
yeah, but
you don't know a lot of things. So a lot of people start using
just do your research and it will eventually help you. You'll learn much more than starting out with Unity, trust me. Do your research, dig deep, and take apart those frameworks, and you'll learn much more.
Depending on the game, who wants to do it.
Obviously, it depends, but you can do these kind of tricks for almost any game. Everything is a trick, right? Especially in graphics right now, everything is a trick. Screen space, ambient occlusion, and the best games do the best tricks usually. They're just higher level than our tricks. Two people when we started, one designer and one programmer, and we ended up 3 or 4 people full-time in the end. Yes, we eventually managed to get a full-time artist, and we were 3 people, and we also worked with freelance programmers and sound guys and everything. Right now we're 4 people, 2 programmers, 1 designer, 1 artist, and yeah, that was it. And it worked really fast just because of this thing, and we're trying to do the same stuff for our sequel, and still with a very small team, 4 full-time people. Yeah. So low cost, high reward.
someone who's just a beginner in programming. Do you think making your own engine is actually a good way to learn to program?
Yeah, to learn to program, yes. But if you really want to make a living out of it, I wouldn't advise. If you really have a good idea and want to make money out of it, I wouldn't advise making your own engine because of the lack of experience. You'll probably be better off using Unity or EDK. But the chances of that working out, very slim. Sorry.
They're mostly used for prototyping and stuff like that.
Yeah, you can do that. It's much faster prototyping, obviously. But usually after you prototype for a month or something, you'll say, okay, now there's no way I'm going back or going to another engine, so you'll just stick with it. So make a wise choice. Okay. 0. Yeah, the thing is, right from the start, we knew we had an idea that was pretty niche and there was nothing like it on Steam or on PC. And we knew it would work. And what we did was go on some niche forums like tactical, where tactical guys went or strategy fans went. And we posted there, asked their opinion, and some magazine editors saw the game there. They wrote about it, and it started snowballing. Once even a small magazine writes about you, other big ones see it, and they'll do an article or something, and it snowballed. So we didn't need any publicity whatsoever. We did invest some money on the iOS version. We paid $5,000 or something, which we never got back. It was a really bad idea. Maybe $500 we got back from looking at the analytics, but yeah, that didn't work. So it's not the type of game. It was a paid game, a premium game, and I don't know if paid commercials work for that kind of games. No, we launched on PC, Mac, and Linux first, and iOS and Android after we finished the initial game.
So the PC is the higher grossing?
Oh, yes, definitely. The PC made probably 80% of the money. And it's not a bad selling game for mobile, but still PC is king. Okay, the final one, because I have to go. If it was developed by me in Unity, I'm just saying, but by me, if I had taken the Unity path, it would have taken longer, and I don't know if we would have finished in time. So by a more experienced programmer in Unity, yes, definitely. Or what was your question? If it had more success?
No, more or less.
No, if someone with experience in Unity, if it did the exact same game, probably would have taken less. But because of the traps that I mentioned earlier, because you want to use those awesome features that Unity puts out there for you, and you'll spend much more time in reality than.
So the main idea is to keep it simple, the design of the game.
Not necessarily the design, but the implementation of the design, the technical part. But also I mentioned, because we didn't have any AI scripting or something, we couldn't do single-player story mode, for example. So that was out of the question. So. Okay, so I guess I'm over time. Okay, thank you. I hope you liked.